Today we will discuss degenerate perturbation theory or twofold degeneracy. So what is a degenerate state? Degenerate state is basically state. Suppose we have state psi of A and it's Hamiltonian, so equal to E dash psi A. And suppose we have another state psi B is equal to E1 psi B. So we have same Hamiltonian, we have different states, different wave functions, even though we have same energy. So these two wave functions psi A and psi B are called degenerate wave functions. The example we can say is the hydrogen atom. We know that the hydrogen atom wave function can be written as NLM. So and okay, and the energy of this psi NLM depends only on the main quantum number n, like energy n is equal to minus 13.6 by n square electron volt. So for psi of n equal to 2, we have L equal to 1 and M equal to 1 and minus 1 and 2 1 minus 1. So for these both two states we will have the same energy E2 as minus 13.6 by 4 electron volt. So in summary, different waves, different wave functions has same energy, and we'll call that as degeneracy. So suppose we have two wave functions. Here for twofold degeneracy we have two wave function of psi naught of A and psi naught of B. So here 0 represents the non-perturbed system, and again we have the Hamiltonian, unperturbed Hamiltonian, H naught psi A of naught is equal to E naught psi A of naught. Same for B. Here the two states psi A and psi B are orthonormal. The linear combination of those two states will be psi naught is equal to alpha psi naught of A plus beta psi naught of B, where alpha and beta are constants. And again, if the Hamiltonian, unperturbed Hamiltonian acts on the wave function psi naught, it will have E naught psi naught. Okay, this here E naught represents the unperturbed system's energy, and we have lambda. Lambda will be varied from 0 to 1. Okay, so before that, what is lambda? So lambda is if we have the Hamiltonian, the final Hamiltonian is the unperturbed Hamiltonian plus perturbed Hamiltonian, let's call it H dash, and here we have lambda. Lambda is just a parameter which is dimensionless and has values ranging from 0 to 1. It tells us that how much of perturbed Hamiltonian, how much of the perturbed Hamiltonian we are getting. Like if lambda is equal to 0, then it will be H, it simply will be H naught, and if lambda equal to 1, that means 100% of H1 will be added in H naught. Here lambda tells us, or here lambda, with lambda we can determine how much of H dash, the perturbed Hamiltonian, we will use. Basically just that. And here if we draw the graph of E, energy versus lambda, we know that the value of lambda equal to 0 to lambda equal to 1. For perturbed for degeneracy, we have, suppose we have two wave function or two states at E naught. So if we increase lambda, maybe the energy of one of the two states will be higher and one of the two and the other will be lower. So this tells us the splitting, not split. Okay, here if we introduce the perturbation as H dash, we'll get H psi equal to E psi, where H is the perturbed Hamiltonian, which can be written as H naught plus lambda H1. Lambda is ranging from 0 to 1. E can be written as E naught plus lambda E1 plus lambda square E2. Here E naught is the energy of the unperturbed system, E1 is the energy of the first order correction, E2 is the second order correction in energy. same goes for psi, the wave function. Here is the unperturbed wave function, first order correction, second order correction, and so on. It can be noted that E naught is less than or equal to E1, less than or equal to E2, up to so on. Putting the value of H, E and psi in this equation and comparing the coefficients of lambda, we'll get the equation H naught psi 1 plus H1 psi naught is equal to E naught psi 1 plus E1 psi naught. Let's by taking inner product with first degenerate state psi naught of A, we'll get psi naught of A H naught psi 1 plus psi naught of A H1 psi naught is equal to psi naught of A E naught psi 1 plus psi naught of A E1 psi naught. We know that the H naught is the Hermitian, so this can be written as so this goes to here, H naught psi naught A, like Hermitian means inverse will be H naught, yeah, and so H naught psi naught A equal to E naught psi naught A for the unperturbed system. So basically E naught psi naught of A psi 1 plus psi naught of A H1 psi naught, and so here is this constant, so we can put it outside. E naught psi naught of A psi 1 plus same goes for psi naught of A E1 psi naught. These two quantities will be cancelled out, and here psi naught of A H1 we can write psi naught as the linear combination of the two different waves functions, the two different states, psi naught of A and psi naught of B, as alpha psi naught A plus beta psi naught B. And same goes for psi naught of this. We know that the inner product of psi naught of A and psi naught of B will be 0, and that of for psi naught of A, psi naught of A will be 1, because psi naught of A and psi naught of B are normalized. Thus by alpha inner product of psi naught of A H1 psi naught of A plus beta psi naught of A H1 psi naught of B will be alpha 1. Let WAB be psi naught of A H1 psi naught of B, that is the inner product of two state A and state B with the perturbed Hamiltonian H1. So for WAA it will be psi naught of A H1 psi naught of A, and same goes for WAB. So rewriting this equation in form of WAB, we get alpha WAA plus beta WAB is equal to alpha E dash. Let's call this equation 1. If we take the inner product of this equation with psi naught of B, we'll get by following the same procedure, we'll get alpha WBA plus beta WBB is equal to beta E dash. Let's call this equation 1 and this is equation 2. Multiplying equation 2 by WAB, we get alpha WAB WBA plus beta WAB WBB is equal to beta WAB E dash, and the equation 1 is same as alpha WAA plus beta WAB is equal to alpha E dash. So putting the value of beta WAB in this equation, here beta WAB and beta WAB, we get this form, and by rewriting this form, so we'll get alpha WAB WBA minus E1 minus WAA into E1 minus WBB is equal to 0. We have two conditions again. If alpha is equal to 0 and alpha is not equal to 0. Suppose alpha is not equal to 0, then this term should be 0. So WAB WBA minus E1 minus WA into E1 minus WBB is equal to 0. And solving this for E1, we'll get this form, and E1 will be WAA plus WBB plus or minus square root of WA plus WBB square minus 4 WAWBB minus WAB WBA divided by 2, which is basically B square minus 4AC minus B plus or minus by twice A. By rewriting this equation, we get the final equation as as energy plus or minus E1 as a half of this term. So these are the energies, these are two energies. We got E dash plus and E dash minus because we had two states, two degenerate states, and psi naught A. If we have three degenerate states, then we'll get three different energies, and for four we'll get maximum four different energies. And what if alpha is equal to 0? Then from these two equations, just put alpha is equal to 0. So it will be, first equation will be beta WAB is equal to 0, and the second equation will be beta WBB is equal to beta E1. And so E1 is equal to WBB. What is WBB? It is the inner product of psi naught B and psi naught B with the perturbed Hamiltonian H1. So this is basically just tell that this is the first order energy correction for the unperturbed unperturbed theory. And what is the final wave equation? Psi naught will be beta psi naught of B as alpha is equal to 0, and this wave function is normalized, or this one, so beta is equal to 1. Same goes for if beta is equal to 0, then the psi naught will be alpha psi naught A, and this is also normalized, so alpha will be 1. If we have n-fold degeneracy, that is we have n different states with same energy, so suppose this is the first wave function, second wave function, third wave function, and the energy is E naught, and the linear combination of these degenerate wave functions as alpha 1 psi 1 of psi 1 naught plus alpha 2 psi 2 naught plus alpha 3 psi 3 naught plus up to plus alpha n psi n naught. So for two-fold degeneracy we had two equations. For n-fold degeneracy we'll have an equation with n square matrices, w n square w matrices. So the equation can be written as alpha 1 w1 plus alpha 2 w12 plus alpha n w1n as alpha 1 E1, and same goes for alpha n wn1 plus alpha 2 wn2 plus alpha n wnn as alpha n E1. Now rewriting this equation in the matrix form, we get w11 w12 to w1n, w21 w22 up to w2n. For the column we have w1n n1 wn2 up to wnn, and alpha 1 alpha 2 up to alpha n as E1, alpha 1 alpha 2 up to alpha n. In order to find energy for n-fold degeneracy, we just need to find the eigenvalues of these matrices, and that's all. We'll have the different energy for different states. Check the description to find the material I use for this theory.